Imagine a world where the building blocks of life, DNA, can be edited like text in a document, where the food on your plate has been transformed not by nature, but by human hands, in labs far from farms. This isn't science fiction, it's the story of genetically modified organisms, or GMOs, a global revolution that began in a petri dish and exploded across more than 200 million hectares of farmland. But is it safe? Who controls it? And what does it mean for the future of your food? To understand GMOs, we must go back, way back. Long before the term genetic engineering existed, ancient farmers were practicing their own kind of genetic manipulation, selective breeding. Corn, for example, evolved from a grass called teosinte through centuries of careful cultivation. But this slow generational process gave way to something far more powerful in 1953, when James Watson and Francis Crick, building on Rosalind Franklin's research, uncovered the double helix structure of DNA. For the first time, scientists understood life at its most fundamental level. Fast forward to 1973, biochemists Herbert Boyer and Stanley Cohen achieved something extraordinary. They insert DNA from one bacterium into another. This isn't just a new technique, it's a biological moon landing. For the first time, life itself could be rewritten. A decade later, this technique birthed the first genetically modified medical product, insulin made from engineered E. coli bacteria. It was cheaper, more accessible, and life-saving. From there, the floodgates opened. In 1994, the Flavor Sava tomato became the first genetically engineered food to reach American shelves. Designed to resist rot and extend shelf life, it marked the debut of GMOs in our grocery aisles. But the tomato was short-lived. It flopped commercially, not because of safety concerns, but because it just didn't perform well in the field. Then came the giants. In 1995 and 1996, crops like BT corn and Roundup Ready soybeans hit the market. These weren't just slightly modified plants, they were designed as part of integrated systems. BT crops contained a gene from a soil bacterium, Bacillus thuringiensis, which made them produce their own insecticide. Roundup Ready crops could survive glyphosate, a powerful weed killer, meaning farmers could douse fields in herbicide without harming the crops. It was convenient, it was profitable, and it was everywhere. By 2023, over 200 million hectares of farmland were planted with GMOs, most of it focused on just 4 crops: corn, soybeans, cotton, and canola. These crops feed much of the planet, but they've also led to a dangerous concentration: fewer crops, fewer genes, more vulnerability to climate change, pests, and disease. So how exactly are GMOs made? Think of it as high-tech cut and paste. Scientists isolate genes responsible for traits like pest resistance or drought tolerance, and splice them into plants using molecular scissors, restriction enzymes, and glue, ligase. The genes are inserted using vectors like Agrobacterium tumefaciens, a natural soil bacterium that acts like a genetic delivery service. Alternatively, they might use particle bombardment, firing DNA-coated particles into plant cells at high speed. Once the foreign DNA enters, marker genes help scientists identify which cells were successfully modified. This process is incredibly precise, far beyond traditional crossbreeding. Yet it brings with it complex questions. Who decides which traits matter? And what happens when these modifications spread beyond the lab? Now to the big question, are GMOs safe? Most scientific organizations say yes, at least for the currently approved crops. In 2016, the US National Academy of Sciences found no evidence that GMOs pose greater risks to human health than conventional crops. But critics point out a key flaw. There's a lack of long-term human studies, no 30-year dietary studies, no comprehensive tracking of glyphosate exposure over time. So, while the genes themselves may be safe, the ecosystem around them, the herbicides, the farming practices, are where real concerns emerge. The herbicide glyphosate, for example, is classified as probably carcinogenic to humans by the World Health Organization's Cancer Research Agency. Meta-analyses show increased rates of non-Hodgkin lymphoma in people exposed to it, and with Roundup Ready crops, glyphosate is everywhere. The story of GMOs isn't black and white, it's a story of breakthroughs and blind spots. It's about feeding billions, but also about corporations consolidating control over the seeds that sustain us. It's about miraculous science and the unintended consequences that science can bring. GMOs are here to stay, but how we use them, regulate them, and question them, that's still in our hands. In the next chapter, we dive deeper into the real battle for control, the seed wars. You'll meet the corporate giants that own the genetic blueprints of our crops, the farmers caught in the middle, and the grassroots movements fighting to reclaim food sovereignty. Seeds, once the shared foundation of human civilization, have become patented property. In fields across the globe, a silent war rages, not with guns or bombs, but with contracts, lawsuits, and laboratory patents. Farmers are being sued. Traditional seed saving is now illegal in many cases, and at the center of it all is a new kind of empire, an empire built on genes. Welcome to the seed wars. This isn't just a battle for crops, it's a battle for control over life itself. Let's start with how we got here. In the past, farmers saved seeds from one harvest to the next. It was a tradition going back 10,000 years, simple, efficient, and self-reliant. But with the arrival of genetically modified seeds in the 1990s, everything changed. Biotech giants like Monsanto, Syngenta, and Bayer entered the stage, not just as suppliers, but as owners. Through aggressive patenting, these corporations turned seeds into intellectual property. Farmers who buy genetically modified seeds must now sign technology use agreements. These contracts strictly forbid saving or replanting harvested seeds. Instead, they must repurchase them every year. The precedent was set in 1980, when the US Supreme Court allowed the patenting of a genetically engineered bacterium that could consume oil. This opened the door to patenting living organisms, and with it, entire genetic codes. The commercialization of life had begun. The genius, or danger, of this model is how it creates a closed loop. A company produces a genetically modified seed. That seed is designed to work perfectly with a specific herbicide, which the same company sells. Suddenly, the farmer needs both the seed and the chemical, and only from one source. It's not just a product, it's a system, and the farmer is locked inside. This system creates ongoing revenue for corporations, but also new burdens for farmers. If a farmer reuses patented seeds, even unintentionally due to cross-pollination from neighboring fields, they can face massive lawsuits. And many have. Monsanto alone has filed hundreds of lawsuits against American farmers for alleged patent infringement. But this isn't just about legal contracts, it's about biodiversity and sovereignty. With GMOs dominating the market, agriculture is shifting toward a monoculture model. Only a few crop varieties, soybeans, corn, cotton, canola, are planted on a massive scale. This reduces the genetic diversity of our food supply, increasing vulnerability to pests, climate shifts, and disease. Contrast this with the early 20th century, when scientists like Nikolai Vavilov collected thousands of local crop varieties across continents. Vavilov believed diversity was the key to food security. His work laid the groundwork for today's seed banks, places like the Svalbard Global Seed Vault in Norway, which now houses over 1 million seed samples in climate-controlled Arctic conditions. But even with this preservation effort, the real-time erosion of genetic diversity continues. Farmers are pressured, both economically and legally, to use high-yield GMO varieties instead of local traditional ones. This erodes the adaptability of agriculture and our collective food resilience. In response, movements have emerged across the globe. Leading the charge is Vandana Shiva, an Indian environmental activist and physicist. Her organization, Navdanya, promotes seed sovereignty, the idea that farmers should own their seeds, not corporations. Across India, Africa, and Latin America, farmers are resisting GMO dominance by reviving traditional seed exchanges, planting heirloom varieties, and building local seed banks. These movements argue that GMO systems increase farmer dependency, threaten food sovereignty, and dismantle centuries-old agricultural wisdom. They're not anti-science, they're pro-choice, demanding alternatives to a monopolized system. So where do we go from here? The seed is the beginning of all food. Who owns it, who controls it, determines everything that follows. Right now, a handful of corporations control much of the global seed market. But farmers, scientists, and citizens are pushing back. From seed-sharing cooperatives to open-source genetics, a new era of resistance is blooming. The question is no longer just about what's on your plate, it's about who has the right to grow it. In our final chapter, we'll confront the big question: are GMOs truly safe? And what are the hidden risks behind the science? You've heard it all. GMOs are completely safe. GMOs will kill you. But what's the truth? We've had GMOs in our food system for over 25 years. They've been approved by governments, backed by billion-dollar corporations, and consumed by millions. But are they truly safe? Or are we part of a vast, untested experiment? Let us peel back the science and the spin to finally answer the question: are GMOs safe to eat? First, let's look at the official science. Major institutions, including the World Health Organization, the FDA, and the National Academy of Sciences, generally agree that currently approved GMO crops pose no greater health risks than conventional crops. In 2016, a major review by the US National Academy of Sciences concluded that genetically engineered food is safe to eat. It emphasized that GMO crops are not inherently more risky than their conventional counterparts. But here's where it gets complicated. The same report also admitted a serious gap. There are no long-term epidemiological studies, meaning studies that track human health over decades to see the effects of consuming GMO food or being exposed to related chemicals like glyphosate. So yes, the science says safe, but it also says we haven't looked deeply enough. Most health concerns about GMOs don't stem from the altered genes themselves, but from the chemicals they're paired with. Take glyphosate, the active ingredient in Roundup. It's sprayed across millions of acres of glyphosate-resistant crops, including soy and corn. In 2015, the World Health Organization's Cancer Research Arm classified glyphosate as probably carcinogenic to humans. Follow-up studies found a 36% to 41% increase in non-Hodgkin lymphoma in people heavily exposed to glyphosate-based herbicides. That's not a conspiracy theory, that's peer-reviewed science. And yet, the FDA still allows glyphosate residues on food. Regulatory bodies argue the levels are low, but what about bioaccumulation? What about children consuming it regularly? These questions remain largely unanswered. GMO crops were supposed to reduce pesticide use, and in some cases they did. Bt crops, for instance, produce their own insecticide, reducing the need for external sprays. But nature always fights back. In less than a decade, we've seen the rise of glyphosate-resistant superweeds, which now infest millions of acres in the US and beyond. Some are 7 to 11 times more resistant than normal weeds. Farmers now have to spray more chemicals or switch to even more toxic options. Same with Bt crops. Insects evolve, resistance spreads, and we enter an agricultural arms race that's difficult and costly to win. Meanwhile, biodiversity suffers. Broad-spectrum herbicides wipe out everything but the crop itself. This includes flowering plants and weeds that pollinators rely on. Long-term studies suggest potential harm to non-target insects, but the true ecological cost may take decades to unfold. In the United States, GMO regulation is handled by 3 agencies: the FDA, EPA, and USDA. Their approach is based on substantial equivalence. If a GMO looks and behaves like a regular crop, it's treated the same. But Europe disagrees. The EU follows the precautionary principle: if there's doubt, slow down. They mandate GMO labeling and rigorous safety reviews. In 1997, the EU became one of the first places to require transparent GMO labeling. Many European countries have outright bans on GMO cultivation. Other nations like China and Brazil mix both approaches, pushing GMO development while keeping an eye on environmental and trade risks. The result? A global patchwork of rules and consumer trust levels. The truth is, GMOs aren't just a scientific issue, they're a systemic issue. The technology itself may be safe, but the farming systems, the herbicide dependencies, the corporate ownership models, they carry real risks. This isn't about fear-mongering, it's about asking better questions. Not just, is the gene safe, but what does this technology enable? Who profits from it? What do we lose along the way? The future of food will likely include GMOs, but it must also include transparency, accountability, biodiversity, and respect for farmer independence. You now know the truth behind GMOs, the science, the controversy, and the system. If this series changed how you think about food, share it. Like, comment, and subscribe. Join us as we continue uncovering the unseen forces shaping our food, our planet, and our future.